I haven't unmuted myself. Yeah, sorry guys. Okay, good. Let's go from the start. Welcome everybody to Computer Science 1A lecture. Okay, a little bit of a lightheartedness there. I was talking like you wouldn't believe it. I was halfway through the lecture already. Anyway, welcome to Computer Science 1A lecture. The objective of this evening is we're going to work through the mark sheet of our typical semester test and the exam. And we're going to go through each of these little competency components and just quickly describe where it is. For those that have joined us in the prac lectures for the last 2 weeks, normally on the Fridays, because our previous pracs 7 and 8, and obviously 9 as well, they're actually based on this specific mark sheet. You'll see that I have already described it there. Once we've worked through this mark sheet, I'm going to spend some time on the bonus marks, how you can get some bonus marks and some tips around that. Okay, and then see how it basically pans out. Now what you'll see is this is typically how your semester test and the exam looks like. Okay, it starts with this front page, explains who the assessor is, the moderators, the duration, and some instructions here. This is how you should upload, name, etc., etc. Don't worry too much about the naming in the semester test, because you are going to upload and you're going to make use of the VPL, and you're going to download your final submissions from the VPL. It's already in a zip format. You don't have to go change anything in that zip file. You take that zip file as is and you upload that to Eve. Okay, so it's going to be very, very simple to submit this year. But remember, I think I did mention this yesterday, but it's definitely mentioned in the email, or I can't remember if I mentioned in the email. Okay, anyway, let's just mention that your submission on Eve is seen as your final submission. That means you're only going to be able to upload once onto Eve. So don't upload anything to Eve if you are not ready to hand in. That's basically what it boils down to. You will be given time after the timer has expired to actually go to the VPL, download your stuff from the VPL, and then submit that onto Eve. You're not going to have a super amount of time to do that, but by this time you guys should know basically how to download and upload stuff. Okay, so that's what's going to happen on Friday with regarding submission. And just remember that what I've said now for submitting onto Eve. Don't submit anything to Eve if you're not ready for that version to be marked. If you do submit anything on there, you will not be able to submit anything else, and we will mark whatever is on Eve at that point in time. Okay, so let's go on. So what we see here, this is the mark sheet that all the exams and the semester tests use. They have these competencies on the left-hand side from C0 to C10 actually, and then they've got a B for a bonus, which we will talk about a little bit about today. And I just want to make note that C9 may look a little bit different for the semester test and the exam, because structures weren't part of the curricula for the semester itself. The marks will be slightly differently allocated in this section of the mark sheet. But let's just go through the mark sheet and let's see how marks are awarded. So firstly, you get 10 marks for the program design. Now here's a tip. For the guys that's writing on Canvas, you will do your design on the semester test sheet script that we will give to you. Please do not waste too much time on the UML. So do whatever you can. So what are the sections again in the design? You've got your problem statement. The problem statement should reflect whatever is asked in the actual question. So there we go. C0, create a program design. The entire design, including the UML, must model the movement function for this specific paper. Okay? It will be different for the semester test too, but go down until you read C0 and you know exactly what your design should be focused on. So you start with your problem statement, which should reflect something like this. Then there's the input and output data. So how do you get data into that specific model, and how do you get data out of the model? Third thing is your variables that you're going to need, your data, the types that you're going to need. So I'm going to need potentially a destination row, a destination column, and all of these things, and the types. The fourth one is your pseudocode, and the fifth one is the UML. If you are not 100% sure about the pseudocode and the UML, specifically the UML, which can take some time, leave the UML portion until the end. Okay, but try to get at least the 4 sections there with some stuff in there. Worst comes to worst, you get 1 mark for each of those sections and you get 4 marks already. Okay, don't just throw these things away. All add up. Okay, so that's the program design. Must be done with the pen and paper on the sheet itself. For those writing remotely, you will probably have to do an electronic one, which you will have to submit together on the zip file as well. I will just get Prof. Coulter to provide clarification on that. But I mean, you will get special communication for those writing remotely. Next is this C1, which is boilerplate code, 5 marks. Now, there is no reason why you should not get 5 out of 5 marks for this. Now, let me demonstrate what we mean by boilerplate code. If we look at my existing solution that I've done through the this few lectures, boilerplate code is basically anything in this, or most of the, well, not most of the basic components in the main.cpp. Remember when you open code blocks and it creates that very basic hello world? Most of that is actually boilerplate code. It's effectively this standard library here and maybe some of the standard libraries that we have inside our header file. But effectively is, are you using some C standard libraries? Are you using the standard namespace, or at least are you referring to the namespace std somewhere in your functions? And then at the end, are you returning something from the main function? And that is boilerplate code. Let's go back here. Standard namespace, system library inclusions, and indicating successful termination of the program. 5 marks. Very simple. Next, we look at the coding style. Naming of variables is 1 mark, indentation is another, using of comments, use of named constants, program compiles without issuing warnings. Okay, so what we physically do is we normally would rebuild your application from scratch so that it recompiles everything, and we see if there are any warnings. If there's warnings, boom, 1 mark subtracted. If there's no warnings during compilation, we don't subtract a mark. Then we look at how are you using your variables in the system. Do you have named constants? Now, that is very simple. We typically go in the header file and we see you're making use of named constants. Yeah, right, that's another mark for you. We see, are you using comments? Now, the comment section, people always ask me, how much comments must they have in? You put comments in where it makes sense. Now, normally, you don't have to go in too much, like you'll see for me. I mean, here's the basic comments like defining constants. Here is some comments regarding output. Here's my exit values. This actually describes these components. If we look at the actual implementation, all right, I could have probably added a few more comments here with the getInt. If you look at my code, for instance, from last night's tutorial, you'll see it's a much better commented. Here are a few comments. So we do evaluate, how are you using comments? Are you actually helping whoever's reading the code to understand what you did here? You don't have to give too much detail, as long as you provide some detail for your functions, then that is good enough. Next is the indentation. Indentation means, is it readable? We actually do look and see, you'll see that my code is all nicely indented. So for instance, this level of code in the for loop, you can actually follow this little lines down, actually is nicely closed down there. All the code in this level of blocks are all together. This code's all together. These code all are nicely indented, and it makes it for neat and easy reading. But students do weird things. They would do things like this, and then they would, I don't know, oh my goodness. Do weird, then I'm doing it again. I just keep on doing that. And that, and then do that, and then they will have some spaces open, and then this is like that. I mean, that is just very, very messy. And for that, we look at how easy readable is your code. All right, so please try and make neat code so that it's nicely indented. Indented meaning spaces before your code so that it's easily readable. Next. All right, so that is, and then we look at your naming of the variables. Are you using a consistent standard for naming variables? So you'll see that the way that I typically use my variables, if it's for variables used inside for loops, I use very simplistic variables like R, C, and N. If it's variables that we use for parameters, I typically use this camel case, so it's lowercase with whatever type is in front, and then like that. As long as it's consistently applied, so as long as you've got some standard and consistently applied, that should be okay. All right, but the variables must also at least make sense, not int x and int b and int whatever. It must at least provide some description of what this variable is used for. Next. Then we look at your functional abstraction. So are you making your functions as, meaning, do you have a function or code that is just lines and lines and lines of code? And if you've got, for instance, many or sections where you've got big portions of code, are you sure you couldn't break it up into smaller pieces? To make it a little bit more easier to understand what's actually happening inside that section. So that's what we look at. Another thing is, wherever you've got a case where you potentially have duplicate sets of code, then that is a negative principle for you, because when you write functions, you actually want to minimize the duplication of code, because that actually reduces repetitive code and potential mistakes that you have. So those are the things that we can look for. Again, you can get very good marks here if you've been applying the principles that we've been teaching you in computer science. Next is separate compilation. There is no reason that you guys cannot get 10 out of 10 here. Are you using a header file? I mean, by this point in time, this must be second nature already. Yes, I'm using a header file. Am I using the header file inside my implementation and inside main? Yes, I am. Am I using a programmer-defined namespace? Here I've created my programmer-defined namespace in the header as well as my implementation, and here I am using it. All right, make sure that the namespace is exactly the one that's being asked for. Okay, so it should be important that those things matches up. I mean, you can't just out of your head start making up your own namespaces here. That's not what the prac actually asks for. Okay, so that's, are you using guard conditions, the if not defined in front of the in the header file? So this stuff, are this properly defined with the defined there, and here at the bottom end if. So these are all guard conditions that's also part of that. And honestly, you should be able to do this by now. It should be very, very simple. I mean, 5 marks for using and defining the programmer-defined namespaces. That is so simple. Get 10 marks for that. Next, are you using a menu system? Have a look at that. 5 marks for a menu system. By this time, you guys should also know that a menu system should be fairly easy to build. We do look at how easy it is to use your system. So try to use keys presented to the user of the system that kind of makes sense. So for instance, if we ask you to move a player around in the world, and you say that, well, to move left, we're going to use the key 1. To move right, use 2. To move up, use 3. To move down, use 4. That's a little bit difficult for the system to use, okay? And that may count against you, but very, very little in your menu system. We do also look at what else might be appropriate. For instance, if the game asks you to output certain things so that we can see, for instance, the health of a character or whatever, then put that in your menu system as part of the components. Then, are you using input, output, and error streams appropriately? That means if you're supposed to output errors, use the CERR, okay? Don't go ahead and just use couts here. For instance, here we're using user-defined error checking, use CERR. That's the correct place to do it. Have at least a CIN in your code somewhere, so that we know that you're getting some input from the user and you are putting that in some kind of variable. There's my CINs, and of course using COUTs for the normal input and output. Next, command line argument handling. We've discussed this many times as well. Are you properly overloading your main function? For those that don't know what overloading main function is this. Are these variables inside your main function, or these parameters? Boom, 1 mark. Are you then using it appropriately? So there we do look at what is appropriate. So that means if the problem, and that's why I've been stressing so much about making notes. So if the problem says that you need this and you need that, and this must be part of the, I make notes about that, and I actually do counting, and that is part of the things that we actually mark. So in this example, this specific implementation required 1, 2, 3, 4, 5, 6, 7, 8, 9 different command line arguments, which includes obviously the program name, and that's why we look at something like this. Are you testing whether the total number of command line arguments is equal to what is required? And then, are you using it properly? So here we go. Command line argument 1 is supposed to go into rows. Command line 2 is supposed to go into columns, and that kind of stuff. So are you using them somewhere? Not just testing it and then not using it anywhere in your code. Make sure that you do use them. Okay, what is next? So that was command line argument. Again, very simple. Please, it's not that difficult to get full marks here. Next is error handling. So the first thing there is the use of assertions, and for that, 2 marks. So guess what? At least 2 assertions. Now, where are places where you can use assertions? Now, if you look at your implementation file, a simple place to use assertions is in the getrand. So inside getrand, this is a very nice place to put it in, because programmers typically make mistakes in this line of code. So make sure that int lower is less than int upper, as an example. So that's a nice, easy place to put in an assertion. Another place to put in an assertion is wherever we deallocate the memory for our 2-dimensional arrays. So here I'm allocating memory. Let's have a look and see where I'm deallocating. My machine is a bit slow now. Okay, let's see. Deallocate. There we go. Deallocate. So here's another place to do an assertion. The reason why we want to assert in this place is because if a programmer calls the deallocate function before you've actually allocated memory for this 2-dimensional array, then it's used incorrectly. So this is another place to put an assertion. So we can say assert that array world is not equal to a null pointer. Because remember, afterwards, we will actually set it to a null pointer. So if we do call this function out of turn, then this assertion will fail and the program will provide an error. So those are at least 2 places to very easily put in assertions. There's a few other places as well, but remember, it's for programming checks and balances. Let me think if there's anything else for assertions that's important that I should mention. I can't remember any more. The next section that we do look at is user. Where are we? Use of conventional error handling techniques. What I normally do to actually look and see if you actually have used conventional error, I look for CERRs and see where did you use your CERRs. And here is a nice example of where we use conventional error handling. So we did see, could it convert successfully? Okay, so this is one place where we've used CRR, and that means it's at least one of the places. Another place is obviously when we evaluate the movement, or potentially if a mistake has been made somewhere in the 2-dimensional array, putting it like the default case, that's another place where that's a nice place to have it in. Okay, so that's what we have in the implementation. Another place is right here. This is also part of conventional error handling. So can you see how command line arguments and conventional error handling actually can give you, but just doing a little bit of code gives you a lot of marks. Okay, these are all conventional error handling places. And of course, another place where you can potentially use it is in your range checking. But I mean, it's 3 marks, so at least 3 places, né? That kind of makes sense. Next is pseudo-random number generation. So what we typically do there is we look at how you handle pseudo-random number generation. Firstly, are you seeding the random number generator properly as expected by the solution? If the solution doesn't specifically say how you should seed it, then this is a very good way to seed the random number generation, which is using the time function. So that is at least worth 1 mark. And then the rest of the marks, we try to find out where did you use the rand function. Oh, here we use the rand function. Is it used properly? Okay, you've actually got this thing where you can generate a random number that is exactly in between 2 numbers. You did actually calculate it properly so that it will generate a random number between these 2 numbers, implemented properly, 5 marks. And I mean, even if you don't understand this, just learning it from heart will pocket you 5 marks in the system. Next, now we get to the sections where we are a little bit more pedantic and a little bit more strict. Okay, so both C9 and C10 are a little bit more strict towards how we allocate marks. So C9, the focus there is on allocation, deallocation, and initialization. No, not structures, because we haven't covered structures. So at this stage, I'm not sure how Prof. Coulter did the mark sheet arrangements, but I know for the semester, for the past pracs, I said 5 marks for allocating, 5 marks for deallocating, and 10 marks for initialization. And this has to apply to the actual scenario. So with allocation, this is fairly generic even. So here we look at the new keyword. Where are you using the new keyword in your solution? Here we go. So we are using the new keyword here to allocate a 2-dimensional array. Okay, looks like it's done properly. Boom, 5 marks. The next section is we look at the deallocation. So where's the delete? Here we go. You're first deleting it inside the little for loop, so that's fine. Afterwards, you're deleting the 1-dimensional array of pointers, and then you're setting the variable to a null pointer. Are you passing the parameter by reference, and are you actually calling the deallocation? That's quite important. It doesn't help much if you have the super function to deallocate memory and you're not actually using it. So normally we will actually try to find out where you're using it. In this example, I'm using it in this place at the bottom of the main function, but I'm also using it in other areas as well. So these are typical things that we look at for allocating and deallocating. Now for the initialization, this is where we now look at the details of the app. Can you see so far me as a marker, I have no idea except for the command line arguments what is actually in here. Now I look at the details and see how must the initialization work. Oh, so this is how the initialization should work. Must be raised randomly, blah, blah, blah. Okay, let's see how the student implemented this. The student implemented, hopefully, this inside some kind of initialization function. Okay, in this example, they did. Okay, I see they passed that. This makes sense. They did it this way. Okay, so here they placed the characters. Here they place the infected characters. Here they place the susceptible characters. This makes sense. Boom, it's all good. I don't see any flaws in their approach. Boom, 10 marks. If, however, there are certain things that you did not approach or certain requirements for initialization that wasn't done properly, then you will lose some marks there. Okay, so how complete did you do the whole initialization of the system? That's where you will start losing marks. The next section is the algorithm section, or the algorithm implementation. Now here we look at the whole, how did you handle the movement in this example? How did you handle the update? How did you handle the end simulation? All right, so this is very easy. If you haven't done everything perfect, then you will not get full marks here. But we do also look at what level of effort have you made to try and to get as much done as possible. And just to show you, I mean, this thing counts in this example only 15 marks. So worst case scenario here, if you haven't done anything in that section, you will lose 15 marks. But I mean, if you can get some basic movement happening, you might get about 2 marks, maybe 3 marks, and then start looking at what else were required. That's how we start adding marks. We normally put some weights against it, so we will say, okay, for if you did the movement section properly, that will give you 5 marks. If you did the update section properly, you will get, because this actually is probably the more movement and update are the more complicated. So movement together, that's probably 7 marks. Update is probably 7 marks in this example. And maybe the end simulation component, it's not that complicated, so maybe the rest of the marks and that, well, maybe not 7, 7, so 6, 6, and whatever is left for the end simulation. And that's how we will approach this. So can you see that the bulk of the actual question paper doesn't have to be implemented for you to actually get good marks. But please remember, it does affect things such as the amount of functions that you have and how you're using the functions. So try your best here, do implement your functions, and see how it goes. And that is the C9 and C10. Let's have a look at some of the questions that might have appeared. Right. Are our notes being checked or what? Hold on. Let's go to the top. Imagine the last lecture before test being needed. Yeah. Will we be able to use past paper code in semester 2 from EVE? Absolutely not. You will never, ever, ever, ever be allowed to use any code from anything that you've ever done. The code that you must write during the semester test and exam should be your own. If we find that you copy code or have used code from past papers, you will be flagged as a potential copy. The code that you write during the semester test must be your own. You can use notes from the code that you've done for past papers to give you hints to write. But if we find out that you've used code from past papers or past tutorials or past submissions, even if it's your own, it will be flagged as a copy. We can finish early. Can we leave? Yes, you can. Will there be lectures next week? Yes, we will have lectures next week. The plan for next week is I will go through the theory and I will do some basic demonstrations of enumerations and structures. And for those students that do like to then try that during the exam, if you're going to write the exam and so forth, then by all means go ahead. But it will at least help you prepare a little bit for what's going to happen in the semester test 2. Can we bring our handwritten notes? Yes, you can. So the UML won't be too tough if you're writing on campus in terms of things like having of your guard, since we are not using DIA. How many comments give you marks? Okay, I think I did handle that. Try to give enough comments. That's basically it. So even if the warning is about used variables, deduct them. Absolutely. If there's a compiler warning and you haven't used the variable, get rid of it before you hand in. It's simple. I mean, why is the variable there if you haven't used it? Remark it out. Does the indentation have to be the way you did it, or as long as there is a standard? As long as there's a standard, consistently, yes. Will marks be deducted if one is using formatted A style? No, it won't. Fun question. Will the assistants be marking our papers or strictly the lecturers? It's the lecturers and some of our senior assistants. So those that's doing their master's degrees and so forth, they will be marking the semester tests. When you say we can bring notes, what kind of notes are we talking about? Handwritten notes. If not, given the header file name, can we name it anything as long? Yeah, the file names we're not too strict around. It's the namespaces that we're a bit more strict. How many assertions? I would recommend as many as you can, but at least minimum 2. Right? If you can get a third one somewhere in there, good. So will there be a reading session or will we start immediately? You will start immediately. Code snippets like RAND, handwritten, that should be fine. Are our notes being checked or what? No. I get error using assert. What might the problem be? I don't know. Depends on the error. An assertion could be used for finding the player. Oh, I won't do that because the assert is for programming errors, and that's not really what assertions is meant to be used for. So I won't use that to find an error, to find a player. Plus, I'm not sure if you can it find a player? It will just give an error if it couldn't find, and that will crash the program. So that's not properly the best place to use an assertion. Can't I use the code blocks to write a code instead of you? We've answered this many times, Mr. or Mrs. Mark. Why? You can use code blocks to write, but you must publish on VPL a lot. What's the difference between Ezra and time? The first line of code, Mr. or Mrs. Tamala, is basically just a code that is compatible with pre-C++ 11. The code that you mentioned next for using the null pointer is code that will work for C++ 11 and upwards compilers. Okay, lower bound, blah, 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 boom, 10 marks. Okay, something I couldn't, what happened here? Okay, so we can get a distinction even if we did not solve the problem. Exactly, you can. Interesting, okay. To get the bonus marks for using C++ 11 features, is there a minimum amount? Yes, there are. Well, not a minimum amount. You get marks for each type. So you're not gonna, if you've got to get like, if you've got like 200 null pointers in your code, you will only get 1 mark for that. Okay, all right. So yeah, I'll go through the bonus marks just now. So what if the code we write during the test is the format that we have adjusted to and is similar to the practice we have done? Okay, that's fine as long as it's your own, Mr. or Mrs. Harper said, and it's not copied somewhere. Can we use the code? Can we use the code Prof. Coulter used in the game framework with video? Again, if you copy the code from anywhere else, it is seen as plagiarism, and your program will be marked as potentially a copy. You must code it yourself. If you code things yourself, the chances are that it will be exactly the same as Prof. Coulter's in the framework video. Then it's very slim. Plus, the code must be applicable to the problem. I mean, if you're going to do stuff in your code that has no meaning or bearing whatsoever to the problem, then why? Okay, why did you use that code? If we're writing remotely and do not own a webcam, what should we do? I think Prof. Coulter did have that in the email, right? So just mention that in the email. He did mention that something, if you don't have anything right, you must fill in a form to specify the problems that you could not do with the proctoring software. What if coding technique for certain parts of my code is generally the same, like in some of my command line arguments, are almost every time? But again, it will be different for the specific implementation. I mean, the total number of command line arguments will be different. The exact types of command line arguments or the way that you will use it as in variables will be different. It can't be exactly the same. Also, like copy, deallocate, copy. Again, this will be based, deallocate will be based on your variables in your implementation at that point in time. Yes, they are the same or they will be similar. And only if we find that there's too much similarity will we flag it. Plus, if it is flagged, you will get an opportunity to explain yourself. So don't stress too much about the copying. If it's your own work, guys, don't stress about it. What if you fail the semester test too? Then you fail it, and then you will probably have a bad semester mark. Remember, for you to be able to write the exam, you need at least 40% for your semester mark and a practical component mark of at least above 50% to be able to write the exam. So you can still fail the semester test too and still get another chance to pass the course by writing the exam. Obviously, well, if you will have to write the exam anyway if you get, I think your final mark or the semester mark is below 70 and you are not an engineering student. Sir, we bring pages to write notes while reading the question. I would suggest rather make your notes on the paper. Well, you're going to bring in a book notes anyway, so you can make notes in the papers that you bring in anyway, so that's fine. These have a standard idea of how to approach the code. I do not understand that it's not likely to have similar code. All right, as I've already mentioned, we will flag it as a potential copy. If it looks too much like anything else, you will get an opportunity to explain. What if my notes are hints on how to implement a certain function would be regarded as plagiarism? Again, you will be flagged and you will get an opportunity to explain. Okay, so when we say copy, you mean that code cannot be non-related to semester problem, like a function? Absolutely. Mr. Omar, are we allowed to bring blank papers? You will be given a blank paper. So if you really want to make notes, rather use that. Can the notes be done in a book? Yes, you can. So our question paper will be printed out and given to us. Now the question paper will be on Eve. It's just the answer sheet you will have a physical paper on. By the way, sir, I had a connection issue, but I might have spoken about how many pracs will be used now. I think Prof. Coulter did mention that in the Discord. I can't remember. You'll have to check that. Are we allowed to bring calculators? You can probably bring a calculator, but that's a little bit unnecessary. The computers have built-in calculators. Okay. Okay, let's get to the bonus marks before our time runs out. So let's go back to what do we see as C++11. Okay, C++11 things are typical. First one is null pointer. Use that once, twice, 3 times, at least you get 1 bonus mark. Another place which you can do for C++11 is if you look at my implementation of the way that I've used the SStream. This is called what we call, I think it's called braces implement or braces initialization. So you can effectively take a variable and you can initialize it to a value by using braces like that. So that line of code, or let's take another example. Let's see if there's maybe something in here. Yeah. So for instance, let's take this line of code, int exit. Let's quickly rewrite that. So we can, for instance, do this, int exit brace 0 doom bomb. Right, save, build and run. That is called, I think, bracing or initialization, and that's a C++11 feature. Okay, simple, ne? Another thing which you can do is you can have some of your functions return an auto. So you can do this. You could say auto, and then you can use trailing. I can't remember the great word now, which basically describes the type. And I think that is also a C++11 feature. Let's make sure I didn't make a syntax error. I don't use it that often. Hey, my brain can sometimes still remember things. Okay, this is another. And I think this is actually worth something like 2 marks because you used auto in front and the trailing type at the back. You can even have something like this. This is a good place to use it because this auto effectively is another place where we're using it because this kind of infers that this type will be an integer. Why will it be an integer? Because this is an integer. We've actually described it there. This is an integer. We've described it there. And that is an integer. So that's why the compiler will infer that that is also an integer. So this also makes sense where you can potentially use the auto keyword. So that's another place. Then I know Prof. Coulter did say that you can potentially use enumerators. Now, we haven't really covered enumerators, but that will be seen as bonus marks. So enumerators and structures, those kind of things do count towards bonus marks. I just want to think what else? Come on, guys. Any other ideas? Any other C++11 things that I'm forgetting now? I can't really remember. So okay, so let's just count how many did I do now. So this is the trailing type function. Okay, so that's at least maybe 1 or 2 marks. This is where we declare a variable with auto. That's at least another 1 mark. Then this bracing initialization, that's another 1 for another mark, maybe 2, depending on how Prof. Coulter feels. And then we have null pointer, which is the 5 marks, which is another 1. Another thing which he did mention, if you use anonymous functions in your code, then that is also bonus marks, at least 2 bonus marks, in fact. Those are functions that uses the lambda expressions. Okay, lambda functions, they are also bonus marks. So if you can get a lambda expression somewhere in here, boom, another place for bonus marks. Okay, so those are quite a few already. Would I have received 10 bonus marks, bonus points? Probably not. But you know, remember, these are bonus. So they add up. They're beyond what is actually required from you to know. But I mean, come on, guys. How difficult is it to put a null pointer in there? How is it to use this type of initialization? How difficult is it to use autos with the trailing types? Those are, I think, simple implementations. There's a few. Okay, is that it's a one? Yeah, it's just a one dash. Okay, Mr. McCann. Let's just quickly see what else have been questioned. Blah blah blah. The question will be printed out. How many pracs? Or we have to bring. If we use a really simple function like that random number generator function, and it's the same as we did it in the previous practice, would it be plagiarism? No, it will not. Remember, if it's stuff that looks too similar or too not really make sense why you're doing it, it may be flagged as a copy. And then you will have an opportunity to state your case of why it should not be a copy or potential plagiarism. This may seem like copying out, but if we use the example auto, does that count? Absolutely, it does count. So Mr. Milne, that counts as a C++11 feature. Is that a 1? Yes, that's a 1. For each C++, yes. Lambda, yeah, have a look at your function. When you guys did the whole function lectures, there's the anonymous functions and what they call lambda expressions are in there. Lambda functions, lambda expressions. Const expression, I can't remember if that is actually a C++11 feature. I don't think so. I think const expression is just a normal C++ feature. So periodic functions, yes. Declaration type, maybe, maybe not. I can't remember which ones of those are all C++11. I'll have to go double check those things. But if it can only be compiled using C++ flags, then that is a C++11 feature. Can lambda function be declared in CPP? Yes, it can. All the examples I've seen uses in the main function. Oh, I understand. All examples I've seen it in the main function. Remember, the idea of lambda functions is to potentially use it as a potential parameter inside a function. Then you can use lambda expressions to help you do that. Now, it doesn't have to be in the main function. That kind of makes sense in most cases, though, where you may use it. But it can be in another type of function where you potentially will call another function. So maybe some kind of function in your implementation which then makes use of another function, and you want to then potentially, depending on what happens, influence what that function does. Examples of where you can potentially handle lambda functions or lambda or what they rather call lambda expressions is where you may have an output function that will output an array of values, and given a lambda expression will then maybe just output every maybe output the prime numbers in the array, or all the unequal numbers in the array, or all the even numbers in the array. That's an example of where you might use lambda expressions. Auto is used when you did not declare it in the header file. Okay, I'm not sure what you mean by declare it in the auto is a type. And the compiler tries to infer the type from however we use it. It doesn't really. Oh, I understand. So declare it in the header. Okay, let me try and just clarify what we used here. Get rand itself. If you're going to use it in something like a header or a function that is not a helper function, it has to be reflected in both the header and the implementation. For instance, if I wanted to use it in get and, so for instance there, you have to do it for both the header and the implementation. Okay, let's see if I made a mistake. I believe it should be fine. Yeah, okay. All right, the way that I obviously just demonstrated to you was just a very simple helper function that I've used inside my implementation file. I've learned about enumerations. Will I be penalized? Absolutely. No. Mr. Mangwa, if you used enumerations in your implementation successfully, then you will get bonus marks for it. Let me see if I can demonstrate how you can make use of enumerations. Okay, so remember this. Now I'm going to forget the syntax. Well, let's give it a go. What can go wrong? I can just get it wrong. So remember how we did this, where we had various numbers representing different things. You can create an enumerator that actually does this for you. So I think it's enum. I think then you give the name. Yeah, it's, let's say, exit values or something like that. And I think then in curly braces, I think you've got the semicolon after that. You actually create what they call a list of enumerated components. So for instance, val empty, comma, val. Let's see if I can get it right. If I can get it right, then this brain isn't too bad. I haven't used enumerators in a while, so let's see if it's correct. Something like that, and then this should be remarked out, obviously. Then now, obviously, when we use this, we have to specify. So basically, what enumerators will do is it will actually. We're out of time, but effectively, it will put the value 0 for this value. That one will have a 1, 2, 3, and 4. I think you have to actually specify the type as well. I can't remember. Whatever. It's probably not going to work. So please don't take this as a lesson. I will prepare this better for next week and see, and I will describe how enumerators will work. Okay, guys, that's it for today. Thank you very much. Our time is, will both semester 2's exams be open book? Yes, it will be. Okay, another one that I've learned about. Okay, so sir, would there be a problem with the marking if we use system CLS instead of? No, it will not. Mr. Sabanda, if you use system CLS instead of system clear or system clear instead of system CLS, not a problem. We will not penalize you for using the other operating systems. Okay, thanks. So can you please upload this? It's already uploaded, guys. Mr. and Mrs. Mashlango, it's on Eve from last night already. Have a look. But yeah, okay, there's not much. I'll see if I can get the enumeration portion right and then get that on Eve as well. Okay, that's it for today. Thank you much. Good luck with the semester test. There's probably one more annoying email that you will get from my side, which is just a little video that explains what you guys are going to have to do on the computers on the day on the lab. The ICS guys, the IT department, requires some signing in that needs to happen on the computers. We've made a video of that so that you guys are at least just aware, this is what's going to happen, this is how you're going to have to handle that. Thank you very much.